Okay, hello everybody. This is Mrs. Hunsucker. I hope you're having a great Tuesday. This is a busy week for us as we wrap up Unit 2 and Cycle 1 already. Um, so to practice for Interim Assessment 1, which will take place the week of the 9th, not sure the exact day or date just yet, but information to follow regarding the date and times for your IA. But you're going to get 100% participation if you can get into the practice interim through Clever and click on Illuminate. You'll sign in with your Google sign in, okay? So this is where you want to start. Illuminate. Let me do this. Through Clever, okay? And you're signing with Google. You're going to click on the assessments, but it is an assessment, but you're not going to click on assessments. You're going to click on portal. Okay, you're going to click on portal. And there's an announcement with all this information in your Canvas. All right, so you're going to click on portal instead. All right, and then you'll get 100 for completing it. So for your participation, it's an automatic 100. And then we have outing day. You may have not heard about it, so I'm letting you know what's out there for y'all on September 25th. It's a Wednesday. There are no live classes for any of your classes on your schedule, and there are outings across the state. The link is actually at the bottom in the notes of this slide. If you can look there, right here, you can fill out that link, that survey to register. All right, with that said, we're covering section 206. It's the triangle sum theorem. We're going to talk about isosceles triangles. And there's one more thing I thought I should add here, the exterior angles theorem. All right, so all three of those will be covered in this lesson. Next, I just want to point out where we are. It's Tuesday, September 3rd, and we're on the last section of Unit 2. We're wrapping up Unit Cycle 1 content. So you're going to have a constructed response for your Unit 2, and you're going to have an IA practice that you're all going to take, mentioned earlier. And then we have the unit test on Friday, and I will give you a recording for the IA1 review. Okay, so let's go ahead and kind of get started here. We talked about exterior angles in the opening slide. It's something that's really a key concept to section 206. So I'm just going to relate this to any polygon, any figure that has sides and is closed. And I want you to notice that the sides of this pentagon are extended. The extension segments are in red. So if you extend the side of the top left side of this pentagon, you end up with an exterior angle in yellow. So exterior angles are formed by extending sides. All the angles that are in yellow are formed by extending the side of the pentagon, and each of those angles are outside the pentagon. Now, I just want to point out a couple things you should have learned already. This angle, let me draw it. This angle from here to here is a straight angle. Okay? Those two angles, the interior and the exterior, their sum is 180. So the measure of an exterior and an interior is 180 degrees because that's a straight angle there. We actually call those angles linear pairs. So that was past vocabulary. You're going to use that the whole year, so I suggest you really understand what a linear pair is. It's two angles formed on a straight line. They're supplementary. And they also have to share a side. So if I darken this side here, that's the side both the interior and exterior angles share. So just be aware of that. So that's a linear pair. The measure of the interior plus the measure of the exterior is 180. And we call that a linear pair. All right, moving on. Now, there's something called the triangle sum theorem. It's not a postulate, it's a theorem as indicated on the opening slide. That is a typo. It's a theorem. It does have to be proven, so we will do proofs of the triangle sum theorem. All right, so all it says is what you already know. The sum of the interior angles of a triangle is 180 degrees. So take a look at angle A, B, and C. They're all inside the triangle. They can be added together, and the interior angles of a triangle add to 180. So 50 plus 85 plus the measure of angle A is 180. Okay, so if you look at this equation, the measure of angle A plus the measure of angle B plus the measure of angle C is 180. The only thing that's unknown is the measure of angle A. So there's nothing to substitute in for the measure of angle A. So I'm going to substitute angle B with 50 and angle C with 85. And if you add 50 and 85, we get the 135 plus the measure of angle A equals 180. And the measure of angle A ends up being 45 degrees. That's the triangle sum theorem. Say it a couple times. The triangle sum theorem says the interior angles of a triangle sum to 180 degrees. Okay, so we're going to move on. All right, next. If you take a look at what's on the board here, I'm going to erase this and this. All right, again, these are interior angles, so inside a triangle. So to solve this, would you be able to write the equation for solving? So it's going to be 7x minus 20 plus 4x. And that square near angle A means 90 degrees. Equals 180. Triangle sum theorem says all three angles add to 180. If you end up solving this, you would be doing 7 and 4x, that's 11x. And then negative 20 and 90 is 70, equals 180. And then solving for x, you get 11x plus 70. So you get 11, and you're going to subtract 70. So 11x equals 70 from 180 is 110. And x will be equal to 10. Be very careful here. I do want to mention, you read the question. What is the measure of angle ACB? So if we go back here, ACB. So you start at A, go to C. C is the actual angle you're trying to find, and then to B. So it's 7x minus 20, so we know x is 10, so we can just substitute 7 times 10 minus 20. So 7 times 10 minus 20 equals 50 degrees. All right, so the correct answer is 50. It's not 10, that's the value of x. It's gonna try to distract you from the correct answer. Make sure you read the question. All right, moving on. All right, so looking at this diagram, the important thing is the concept of isosceles triangle, okay? An isosceles triangle, what does it look like? How would you describe it to someone to help them? So once you've looked at it, what would be your definition? What is an isosceles triangle? Well, the basic definition is a triangle with two congruent sides. It's that simple. All right. Now, the sides that are marked congruent are actually called legs. So let me spotlight it. Here's a leg, here's a leg. They're congruent. If you circle here and here, those are your congruent sides. So if you take one of the congruent legs and go directly opposite to the angle, that's called a base angle. And you take the other leg and go directly across, that's a base angle. Now, base does not always have to be at the base of the triangle. So check this out. I can draw a triangle this way. These are my congruent legs. Now we have to find the base angles. Once again, I'm going to grab my spotlight. All right, so you go to the leg, go directly across. That's a base angle. Second leg, go directly across. That's a base angle. So base angles are congruent. That's a theorem, actually. The base angles of an isosceles triangle are congruent. We make these little arcs. Okay? Very, very important. All right. So with that said, can you answer the question? Given the triangle ABC, what is the measure of angle B? So I want a base angle. Okay, again, how do you find your base angles? Go to the sides that are marked congruent and go directly across. Those are your base angles. Okay, and remember, they're congruent. So angle C, I use an arc. Angle B, I use the same number of arcs. Angle C and B are equal. So let's call C and B X. Okay, they're unknown. So I'm just going to call them each X. So X, X. All right, can you write the equation for finding the angle B? By the triangle sum theorem, the sum of the three angles of a triangle equal 180 degrees. So let's do 86 is one angle, X is a second angle, X is a third angle, and they add to 180 degrees. Solving, we're going to subtract 86 from both sides. So 86 from 180 is 94. So, and X is 2X. So we have 2X equals 94. X equals 47. Okay, so our base angles are 47 degrees apiece. And I bet you if you plug back in, add all those interior angles up, you're going to get 180 because those are the sum of the interior angles. Okay. All right, so that's the triangle sum theorem. All right, enough said. Trying to keep this short and to the point. All right, so remember we talked about exterior angles by extending the sides of a triangle? So check this out. Spotlight AB. I want to extend it from point B. All right, so now we got an exterior angle B and an interior angle B. That's a linear pair, they're supplementary. Okay, if I extend side AC to the right, extend it, put a point on it, exterior angle is BCY. I have an interior angle and exterior angle. They're a linear pair. They're supplementary. Same thing, AC to the left, put a point on the extension segment and put a point and name it. So angle ZAB is an exterior angle. Remember, the exterior angle A and the interior angle A are a linear pair. They are supplementary. So hopefully you get the idea of how an exterior angle is congruent, is formed. All right, so here's the dun-dun-dun big concept, the king and queen of concepts. Okay, we've got this exterior angle theorem. So the outside angle of a triangle, that's just putting it in words you can understand, is called an exterior angle. The outside exterior angle of a triangle always equals the sum of the two far away inside angles. So exterior angle C is 130. What two numbers do you add together to get 130? Okay? It could be several, 80, 50, 70, 60, that kind of thing. But the point I'm making is if the name of the exterior angle is C, you're going to add the measures of the two other angles together, the interior angles. So 70 and 60 is 130. Interior far away angle A equals exterior angle, or plus. You add those. And then that equals the exterior angle. By the way, the angles, the sum of the two far away inside angles, there's a special name for them. And I wouldn't be doing you justice if I didn't point that out. You'll see words like remote interior angles. Those are the two angles far away from the exterior angle. So now, can you answer the question then? Angle A, okay, exterior angle A. What's that the sum of? What are your two far remote interior angles? Think about it. So we're going to say exterior angle A should equal, I didn't spell that right, or I didn't type it right. That should equal, right? The two other angles are B and C, okay? And you're just going to add their degree measures together. Okay, and then can you do it for exterior angle B? All right. I just started typing like 2 days ago, so. All right, so exterior angle B. What are the names of the two other interior angles, or the other names for the angles of this triangle? It would be A and C. So it would be A in degrees plus C in degrees, and hopefully you're getting the gist, okay? If you have questions, please send me an email. All right. With that being said, all right, spotlight. It says we have this triangle given, triangle ABC, it's this one in here. Prove that the measure of angle ZAB, that's exterior angle A, is equal to the sum of ACB, ACB, that's this interior angle, and CBA, the two remote interior angles, the angles far away from exterior angle A. That would be C and B. That's what we're proving. So we're doing a proof of the exterior angles theorem. Exterior angles theorem says what? What? It says that the outside angle of a triangle always equals the sum of the two far away interior angles. All right, so if we look at this first fill in the blank, the statement says ZAB, exterior angle A, is plus the measure of CAB, interior angle A, equals 180 degrees. Now, they are formed, I didn't want to do that. They are formed on this straight angle, ZAC, right? They're supplementary. So we know that the interior angle A and the exterior angle A are supplementary, but they share a side. I got to repeat myself sometimes, but it's important. They share a side. They're called a linear pair. They're adjacent angles. So that's why we know that ZAB plus the measure of CAB is a linear pair. So that's the first reason we had that statement. Now we got to come up with reasons to justify. So this is kind of like a paragraph proof instead of 2 columns. All right, spotlight. All right, we know that the measure of CAB, we're talking about the interior angle A, plus ACB, we're talking about interior angle C, equals plus CBA. We're talking about all 3 interior angles of the triangle, equals 180. What did you just learn that says the 3 interior angles of a triangle sum to 180? Wait for it. Do you remember? Do I have to tell you? It's the triangle sum theorem. All right. So we're getting there. We're getting there. So now it says spotlight. Use substitution. We have the measure of angle ZAB plus CAB equals. So ZAB plus CAB, that's 180 degrees, right? Is equal to the measure of CAB, the interior A, the interior C, and the interior B. We know that those 3 interior angles sum to 180, okay? So, last statement. So you look at this statement here, this equation. What's missing in the last statement? If you look at the second to last statement. All right, I still say ZAB on the left side of the equal sign. See that? Left side. CAB is gone. On the right side, I still see ACB and CBA, but CAB is gone. So what happened to CAB? It went away. So that would be what property? Subtracts CAB from both sides. Do you know? Subtraction property of equality. Okay, good. All right, let's see if we can clean this guy up. I hate messes. Remember isosceles triangles? We know that. We see the congruent sides. Okay. Those are your legs, right? Remember when we draw a diagonal across from the leg to the opposite angle? Those are base angles. Angle E, interior angle E and interior angle G are congruent. All right. So how are we going to find interior angle E and G if we know that interior angle F is 50? All right. What do you think? Remember, when we don't know something, we can call it X. So this angle is going to be X. This angle is going to be X. All right, let me erase all the other distractions from this. And like a true dork, I erased X. Okay. All right, so those are your interior angles. They're both X because they're congruent angles. All right, so to solve for X, you're going to say X plus 50 is 180, okay? And you can solve it. So 50 plus X is 180. 50 plus 2X equals 180. Subtract 50 from 180, get 130. X is 65. So EFG is X, it's 65. As well as EGF. They're both 65 because they're congruent. All right. And so is this one. All right, make sure you read the question. Okay, EGF was 65, so I can put that answer right here. Getting that degree symbol. And then what is the measure of CGF? Can you find CGF? Start at C, go to G, and then go to F. So it's this exterior angle C. They're supplementary, right? Linear pair, straight angle. CGE is a straight angle. So we can do 180 minus 65, correct? Equals 115 degrees. All right, so that's that. So it's 115. If you have questions, send me an email. Quiz my brain. All right, see if we can wrap this up real soon, right? I will do my best. Yes, I will. All right, so here we go. We want the measure of ABD. ABD is exterior angle B. So that's an exterior angle. Remember the exterior angles theorem? The measure of exterior angle B is the sum of the interior other two angles, right? So if it's angle B, we have two other angles, B and C. You're going to add D and C. We're going to add them together, and that will equal 4n plus 6. So let's kind of go through that really quickly. So we're going to add 2n, spotlight, 2n plus 60 equals this exterior angle. D plus C equals the exterior angle B. Angle B, the two angles far away from angle B are D and C. All right, so we'll set 2n plus 60. You got to add the two remote interior angles. It equals that exterior angle 4n plus 6. And you solve for x, and you get, or n, you get 27, but the question asks for ABD. So it's 4 times 27 plus 6. Okay, and you're going to get choice C out of that. 114. All right, moving on. All right, one. All right, last question. Hurry. All right, can we dig it? We can dig it. Can you set up the equation? You have angle Y. The two other angles in the triangle are Z and X. Angle Y is the exterior angle is 115. The exterior angle sum theorem says the 115, the exterior angle, is equal to the sum of the two far away remote interior angles. Are you able to write the equation? This is a test. All right. So the measure of angle MYL, that's the angle, the exterior angle, MYL is 115. Is going to equal, reading this here, it's going to equal 4K plus 5, that's one remote interior, plus the other remote interior, 6K plus 10. So I'm adding those inside to equal that exterior angle. Solving for K, you get 115 equals 10K plus 15. 6K and 4K is 10K. 5 and 10 equals 15. So we have 10K plus 15 equals 115. Solving for K, K is 10. And that's it. All right, so 3 key concepts: isosceles triangles, interior angle, triangle sum theorem, that's for interior angles, and the exterior angle sum theorem. Thank you. Now take your quiz. Have a great rest of your day.